Okay, sentinel value, ending a loop with a sentinel value. Sentinel value is essentially a value that will end a loop that is not possibly a valid input value. So, for example, if you want to prompt someone to keep entering positive numbers, and it has to be a positive number or it's incorrect, then you may make your sentinel value a negative value, like -1. So if they enter -1, it means they want to end the loop, not that it's a real value. You could use 0 as well, but sometimes 0 is a valid value. So we'll look at the example for the sentinel value right here on this loop. And this particular case says, enter an int value. The program exits if you enter 0. And then we're initializing data as whatever you enter. Sum is just going to sum all the numbers. And so as long as the value you enter is not equal to 0, it's going to simply sum the numbers, prompt you for another number, add it in, and then print the sum at the end. So this is very simple. It's just adding numbers that you enter until you enter 0. So if we go ahead and run this, we'll see if I enter 2, 5, 6, 8, and then 0, it ends, and it tells me it's 21, which would be 2, 5, 6, and 8, which would be 21. Now, I can do this as many times as I want. I can give 0 as the first entry. Then it does nothing. I can give it 2 values. 2 plus 2, 0, 4. So now the loop is not doing something X number of times. It's doing something until you enter a sentinel value. Since, in addition, 0 makes absolutely no sense to add 0 to anything, we can safely say that 0 is the sentinel value. Okay? Any questions on that? What a sentinel value is? And now, if you remember last week when I talked about not using doubles or floats as for exact values, and that's because they could have a very small fractional portion that's really out there way past currency values, but it's technically different than what you're comparing it to. So in a truth test with like an, it may seem that it should work, but it doesn't, because it's got a fractional portion way out, in the millionth place, not maybe the millionth place, but in the 8th place or 7th or 8th place, which is, it's got a hanging 0.00001 at the far right position. And that makes it not equal, because it's got to be an exact match. So, what they're saying here is you should avoid using doubles and floats for a truth test. And a truth test is a while loop, an if statement, or something like that. You should avoid doing that because you may not get what you expect to get. We can give this one a try. I don't know. It may or may not work. I'm not going to spend too much time on it because it doesn't really matter. But let's just go ahead and put it in here. Now, the problem with this is if this doesn't work, we may get what's known as an infinite loop, which is not a good thing. An infinite loop is simply a loop that starts and never stops because it never hits the fullest value. Yes, it is possible to do it on a key press, what we call a key press event. However, Kaza, sorry if I'm mispronouncing, that works only in graphical programs. Well, actually, you can do it. You can do it in character programs as well. If I do this, so what we've got is it looks like it's still running. Now, fortunately, in NetBeans, you can stop this. It's in what we call an infinite loop. Because double, or while that's not equal to 0, I keep on subtracting 0.1. But because of the way doubles and floating points work, I never actually hit it. So, we can go ahead and print out value of item, and what we'll see is it'll just keep going and going and going. See? Oh boy. Infinite loop. Not good. So what you want to do is, like the notes say, avoid using floating point values for truth tests, for especially an exact truth test. Now, I could have said do while item is greater than 0. I would be okay then. Then it would work. Because eventually it's going to hit a negative value and it's going to stop. So that would work okay. Right, so that stops okay. As soon as it hits a negative value, it stops. But an exact match with floating points, very difficult to get it. So you want to avoid that for sure. Okay, our next loop is called a do-while loop. And it's nearly identical to a while loop. The difference is that we are going to test the condition, the exit condition, after we do all the commands at least once. So in a while loop, you can execute the commands anywhere from 0 to many times. In a do-while loop, you're going to execute them anywhere from 1 to many times. And there's a reason why you would do that, actually. Because there may be a situation where you want to do the commands at least once, but you don't want to keep doing them unless something is still true. So you might want to do them at least once, and then keep doing them if maybe something went wrong the first time. Try it again. So a do-while loop is used when you want to do something at least once, but maybe many times. A while loop is used when you may never want to do it. If the condition is false to begin with, you never want to do it. Or you may want to do it many times. So while is 0 to many times, and do-while is 1 to many times. Oh, and you can also see in the flow chart how this works. Essentially, you do the commands first, then you ask if it's true or false. If it's false, you keep going. So even if this statement is false to begin with, you're still doing all the commands once, at least. And if it's true, you stay in the loop and you keep going. So you can always see that the statements are done before the truth test, as we would call it. We've also got something called a for loop. But I think what I want to do is modify some of these things to show you how a do-while loop might be written. Let's see if there's a good example here. This is not it. This is the one I was working on. Oh, sentinel value. So here's an example right here. Don't need that. We'll need to clear int data. We can initialize it to 0. So for this example, and you can see that it shortens it quite a bit by a couple of lines, we know we're going to do this at least once, and we may keep doing it as long as the data is not equal to 0. So the do loop is shorter. We'll go ahead and run this, and it should work exactly the same way. Enter a number. See, now I've only got to put that prompt once instead of twice. So, and then 0, and I get the value. So here's an example that the do while loop works better. It's we probably cut out about 4 or 5 lines of code by doing a do while instead of a while loop. There's your do while loop. Some of these others, a lot of these others could be rewritten as do while loops as well. Guess one number. This one could probably be pretty easily rewritten. So I'm not going to go and rewrite all of them, but a lot of them could be rewritten. Any question on the difference between a do while and a while loop? That one should be pretty straightforward. The next one, the for loop, is different. So, but the do while and the while are pretty straightforward.